Okay, here we are back again for part 2 of 126 years of high-frequency amateur radio innovation. For this part, we'll cover the period from 1930 up through the end of World War II in 1945. And just in case you've forgotten or you're coming in the middle of things, I'll give you my introduction one more time. Hi, I'm Jim Hammarlund, W8KGI, out here in Sandia Park, New Mexico, and I'm privileged to be able to give a little talk to the AWA this year on 126 years of amateur radio HF innovation. I'll step aside and let you see how crazy I am. Well, October 1929 came and the Great Depression hit. The stock market crashed, unemployment was rampant, a third of the banks were closed. And radio hams had very little money, but they had a lot of extra time on their hands. So the decade from 1930 to the beginning of the war became a period of slow but steady growth and steady development, both in the number of amateurs and in the technologies that they were using. As you can see, from 1930 to 1941, the number of hams multiplied by 4 in the United States. This is sort of what happened in that era. In 1930, hams were using homebrew stations, both transmitters and receivers. But starting around 36 and going up to the beginning of the war, many more hams started to use commercially built receivers. Antennas at the beginning of the era were the Hertz and Zepp type, but in the middle 30s, folks started to pick up on various wire and element type beams, even the cubical quad. Transmitters at the beginning of the era were largely single tube Hartleys or TNTs, tuned not tuned oscillators, or the MOPA that Hall was recommending. But Collins came out with their first commercial transmitter in 32. Crystal control became more popular, and there was a circuit that was developed that allowed you to operate on a Crystal second or even fourth harmonic, the triode. Beam power tubes came out in 36. The 6L6 and 807 were great advances over the old Type 10 and the other triodes that people were using. And along about 1938, there were commercial VFOs and band switching transmitters. Receivers developed quite a bit too, from the simple regeneratives through the National SW3, which was a 3-tube regenerative with a tuned RF, to superhets with crystal filters. The Comet Pro and the National FBX had crystal filters. The RME 9 and 69 even had an RF stage, a crystal filter, AVC, and an S meter. The HRO, which came out in 1935 by National, was quite a receiver, and I'll talk more about that later. And in 1936, James Lamb, who had developed the single signal crystal filter in the superhet, even came out with a noise blanker. The frequencies that we had, as you saw out of the 1929 era, were 160, 80, 40, 20, 10, and 5 meters. And we even added allocations at 2.5, 1.25, and 3/4 meters in 1938. Let's look at some of these developments in a bit more detail now. By 1930, almost all the equipment was homemade, and most of the 17,000 licensed amateurs were on 80 and 40 CW, with a few on 20 meters. You could operate phone on 160 and on 50 kilohertz of 80 and on 20 meters with special permission. And you could also operate phone on 5 meters. And there was quite a business in the 30s in 5-meter transceivers, which were modulated oscillators and super regenerative detectors. In 1930, the typical transmitter was a single tube oscillator, either a Hartley or a TNT, running maybe 25 watts to a type 10 or 100 watts to a 203A. Phone transmitters used loop modulation, which was basically coupling a loop attached to a carbon microphone, probably borrowed from your telephone, into the plate tank, which produced AM and FM, I am sure, or Heising modulation, which was a choke-coupled audio amplifier on the B+ line. The audio amplifier was Class A and required quite a bit of power, but it produced decent modulation. AM again. An elite transmitter of the era, especially in the middle 30s, would have a crystal oscillator starting things, a multiplier stage or two, and a triode final amplifier. And power supplies, as we've seen, were thermonic, chemical, or mercury vapor rectifiers, or even motor generators in the early 30s. The receivers in the early 30s were battery-operated regenerative detectors with 1 or 2 audio stages, and generally used plug-in coils to change ranges. So, in the early 30s, virtually all hams were using homebrew transmitters. Eventually, they got better understanding of the design of amplifiers. When Hull was working on his MOPA, he didn't understand how to bias and drive a Class C amplifier. But by the early 30s, a lot more of that information was coming out, as well as designing the tank circuit for an appropriate loaded Q that would give you both decent efficiency and good harmonic suppression. Word of that actually began to appear in QST in 1934, and it continued into the 1940s. Transmitters began to use 47 audio pentodes for a crystal oscillator, and that gave you more output and put less stress on the crystal than the old low mu triode, type 10 triode oscillator circuits. In the end of 1931, QST published details on Class B modulation, which was much higher efficiency than the earlier Heising modulation circuits, and allowed you to get 100% AM modulation. And the triode oscillator that I mentioned before came out in 1933 and allowed you to get output not only at the crystal frequency, but also in the second and fourth harmonics. So you could cover a lot more frequencies with a single crystal. Here's an interesting picture of an early 30s amateur station, top of the line at that point in time. You can see from the call on the wall that it's 1MK, which was the ARRL station at that time, before it became W1AW when Maxim died in 1936. The picture comes from my 1931 ARRL handbook, so you can tell what the vintage is. On the left, there's the power supply room, and you can see that the power is being supplied by a number of motor generators and also by a mercury arc rectifier and filter. I think that may be some of the apparatus in the upper cabinet there, although it could be down below as well. On the right-hand side is the operating room, You'll see the operator's chair over there on the far right of the picture in front of the receiver on the table with a typewriter, an old switch hook telephone, and a box for messages. The transmitter itself is on the table in the left and center portion of the picture. On the left-hand side of the table, there's an interesting transmitter. It's a tune grid, tune plate guy. You can see the two capacitors on the left and right-hand side of that apparatus. And I think the tubes just to the right of that are a pair of 203As. I saw this transmitter a number of years ago in the AWA Museum. Quite a monster, and I think it ran on 80 and 40 and at least 100 watt level, maybe even more. So this is what an advanced station looked like in 1931. Here was that first Collins commercial transmitter that was shown in QST in 1932, the Type 30W. It produced 30 watts of output on 160 to 20, used a 47 oscillator, 27 buffer, and a 10 output amplifier, and cost only $95. Here is a tritet that turned up in QST in March of 1934. It used a 59, which was an audio amplifier tube, and it could be tuned up with appropriate cathode circuits, L1, C1, and output circuits to give you operation on the second harmonic of the crystal that was almost as high as the output on the fundamental of the crystal. You could also operate on the fourth harmonic. So fellas were using an 80 meter crystal to work 80 and 40, and even getting a watt or so out of it on 20. And as you know, 1 watt on 20 meters can still go quite a way. In 1934, suppressor grid and control grid modulation became popular. It was not necessary to spend as much money on all of the audio amplifiers as you would have to equip yourself with a Class B modulator. And things were still hard to buy in the Depression era. Excuse me. So transmitters that might give 100 or more watts output on CW could be grid modulated and give, say, 20 watts or so output on AM, which allowed you to have either an AM or a CW signal. Art Collins developed the Pi network in 1934, which showed up on many, many transmitters, especially in the 50s. In 1936, the first beam power tube was developed by RCA. They developed it to be an audio amplifier for radio sets, but the hams glommed onto it quite quickly and found out that it could be a good transmitting tube, depending upon the 6L6, for frequencies as high as 10 meters. Though I've had a 6L6 that worked on 15 okay, but completely died on 10. But that was dependent upon the individual too. RCA soon came out with the 807, which was pretty much a 6L6 with the plate coming out the top instead of out the bottom. And the 807 became a very favorite medium power transmitting tube well up into the 1950s when the 6146 came out and sort of eclipsed it. The picture here that you see is a Meissner signal shifter. It's a commercial VFO, much more stable than the 1929 Hartley oscillators. And a lot of people bought this signal shifter, or the ones that were developed in 41 and after the war as well, to plug into the place of their crystal oscillators and to provide them with a lot more flexibility as to frequency control on the ham bands. Also in 1940, an electronic keyer came out, which certainly helped signals to become better. Now to go back to my friend Bob Higgy for just a moment. This is a transmitter that Bob built. It was either late pre-war or early post-war. I have an idea that it's probably early post-war, because the crystal socket down here at the bottom on the right-hand side next to the meter was sized for FT243 crystals, which came out and were popular during the war. At any rate, the tube lineup in the transmitter is a 6J5 Pierce crystal oscillator, untuned, feeding a 6L6 amplifier, and Bob and I have used it on 80, 40, and 20 meters. Bob gave it to me in 1964 when I helped him move some of his equipment from his home to an apartment. And the aluminum in the transmitter here on the panel and the chassis probably came from an ET, an electronic transcription, from the WOSU broadcast station that Bob had helped start at Ohio State in the 30s. Okay, we've talked about transmitters over the 30s. This is what was happening to receivers in the 30s. When the screen grids tubes came out, they proved to be very good for RF and IF amplifiers because you didn't have to neutralize them. And a tuned RF stage on a superhet gave you better sensitivity and image rejection. Also, you could put multiple IF amplifier stages together in a superhet without neutralization. In 1932, James Lamb, who was the technical editor of QST, came out with 3 articles on a single signal crystal filter superhet. Actually, he also included regeneration in one of the IF stages. But both the regeneration and the crystal filter provided wildly better selectivity than was available with just simple regenerative receivers or superhets with 1 or 2 stages of IF. So it really gave people the ability to communicate with their signals much more closely together in the ham bands, and was a great boon to stuffing more ham signals into the bands than had been previously available. A lot of homebrewers picked up on Lamb's superhet immediately, and both Hammarlund and National came out with James Lamb crystal filters in their 1933 Comet Pros and FBX receivers. Also in 1936, Lamb came out with a noise blanking, a noise silencing IF circuit for superhets, which was a great step forward. Not only did it just clip the levels of noise, which many noise limiters did in subsequent years, but it actually detected noise peaks and turned off the IF stage for a brief period of time so that it silenced the noise that was coming through. And it was effective on all sorts of noise. It was effective on lightning static. It was effective on automobile ignition noise, or anything else that might be coming along. Here's a receiver that was very popular in its day. National came out with a simple 3-tube regenerative receiver, the SW3. It has a tuned RF amplifier, a regenerative detector, and a triode audio amplifier. And it's thoroughly shielded and built very substantially. And there's no interaction between the RF amplifier and the detector stage, which many of the home-built regenerative receivers had. It covers DC to daylight, at least as far as that era was concerned. You could get plug-in coils that went all the way from 100 kilohertz up to above 10 meters, and you could get amateur bandspread coils for 160, 80, 40, 20, and 10. And it was cheap. $14.42 bought you an SW3, and I think $3 each bought you coils for whatever band you wanted to listen to. Admiral Byrd, when he went to Antarctica on his expedition in 1934, holed up in a remote location over the winter in 1934, and he had an SW3 with him that he used to maintain contact with his home base. There were also a good many SW3s that were being used for communications on sleds and all sorts of things in that expedition. Even today, an SW3 is a very functional receiver, especially on 80 and 40. And I've used my SW3 in some of the AWA contests and also in the Classic Exchange. Here's the Hammarlund Comet Pro, which was one of the first superhets available to hams. It was produced from 1932 to 1935. It has plug-in coils that covered from the top of the broadcast band to 21 megahertz, band spread over the entire range, and later versions of it included, if you wish, a crystal filter and automatic volume control. The Comet Pro was equipped with all of its coils and its power supply and everything else, and sold for anywhere from $96 to $120, depending upon whether you equipped it with a crystal filter and AVC. That was pretty expensive for that era, but still there were quite a few Comet Pros that showed up in ham shacks. Here's the national competition for the Comet Pro, the FB7 and the FBX receivers. National had previously come out with a very expensive AGS receiver, which was for aircraft ground service. And this was sort of a scaled-down version of the AGS. As you can see, it has two plug-in coils that plug into the front panel. Those coils were borrowed from the AGS. And you can get general coverage coils that cover from 1.5 to 33 megahertz, and band spread coils on the ham bands from 160 through 10. The FBX version includes a crystal filter. The FBX sold for $43. The FB7 without the crystal sold for $31. Coils were extra. You could buy a set of coils for $6 and equip yourself for any band that you wanted. And if you didn't have a power supply for the receiver, you could pay National $14 for one of their power packs. So you could start off with an FB7 or FBX for a lot less money than you could for a Comet Pro. Fully equipped, these receivers cost about as much as the Comet Pro did, but you could put them together a piece at a time. And there was even an article in QST that told you how to add automatic volume control and an audio gain control. The only gain control that these receivers came with is that little mouth down under the nose the horizontal dial, which is an RF gain control. And I've got both FB7 and FBX on the air, and they are surprisingly good receivers for 80 and 40 meters. RME in Peoria, Illinois, came out with perhaps what was one of the first modern receivers in the 1940s. The top receiver here is the RME-9D, and it was preceded for a very short period of time by the RME-9, which just had one tuning dial. The RME-9D has both a general coverage and a bandspread tuning dial on the left and on the right. The RME-9D incorporated a tuned RF stage, 2 IFs, a crystal filter, automatic volume control, an S meter, and bandspread. And it covered from the bottom of the broadcast band to 22 megahertz. The next year, RME came out with the RME-69, which you see down below with its companion preselector, which covered up to above 10 meters. And these two were very popular. There were 6,500 RME-69s built and sold in the period between 1935 and 1940 or 41. I have an RME-69. One of the interesting things about both the 9 and the 69, if you look at the dials and the knobs on both receivers, they don't have any labels on them. I actually met Schalkhauser at the Dayton Hamvention one year, and when I realized who he was, I started talking to him about the RME-69 that I had, and I said, "How come you didn't put any labels on the dials?" And he said, "Anybody who gets one of my receivers had better learn what all the knobs do pretty soon, and he won't need labels on the dials." I also asked him why he didn't have any instructions in his receiver manual, which was otherwise quite a bit of information about the receiver and its schematic. Why he didn't put any instructions as to how to adjust the alignment of the receiver. And his answer to that was that anybody who knew how to align a receiver would know how to adjust the alignment on his RME-69. Anybody who didn't already know how to do it had better just keep their fingers out of the receiver and not mess with it. So Schalkhauser was a bit of a curmudgeon, but he made some very good radios, especially in the 30s and the 40s. Now, here's a radio that is perhaps one of the super radios in the 1930s, the National HRO. It was designed in 1934 by James Millen back in Massachusetts and Herbert Hoover Jr. in California. They led the design teams. Millen did the mechanical design of the HRO and came up with that wonderful dial that you see in the center and the tuning capacitor, which is inside, which are mechanical wonders and very stable. And Hoover did the electrical design. The HRO really covers DC to daylight. You can get plug-in coils, which you'll see on the bottom there, underneath the tuning dial, that cover from 50 kilohertz up to 30 megahertz, with band spread on the 80, 40, 20, and 10 meter ham bands. Typically, the commercial HRO came with coils that just started coverage at the bottom of 160 meters and went through 10. The HRO has a much improved wide range crystal filter, which is broad enough for good selectivity on AM phone signals and sharp enough for good selectivity on CW signals. It has AVC and an S meter, and it has two tuned RF stages. that give it sensitivity, as Bill Orr W6SAI once said about it. It has the ears of an Iroquois Indian hunting party. The HRO would even hear antenna noise very well all the way up through 10 meters. It was not inexpensive. The HRO and the coil set cost you $167. The power pack, if you wanted the national power pack, was $15.90, and a speaker was $13.50. And this particular HRO belongs to Bob Higgy, or did belong to Bob Higgy. It was his HRO. And that's the reason I've got a picture of it here with some coil sets sitting on top of it in my ham shack. Bob's HRO was serial number L175, and it was built along with the other serial number L's in February and March of 1936. Bob acquired it in 1938 when he was doing a consulting contract for the Ohio Highway Patrol as an Ohio State engineering professor. And this was part of the payment for his consulting contract. And he used this receiver well up into the 60s when he got a more modern Hallicrafters. He gave it to me when I was helping him move his ham shack out of his ancestral home to an apartment. He reached under his workbench in the coal-fired furnace room and pulled this guy out and dusted maybe a quarter of an inch of coal dust off the top of it, and gave me the receiver and its power supply and a homebrew speaker that he had made for it. And he asked me to take care of it for him. And I've been doing that ever since 1966. Interestingly, James Millen's personal HRO was out of the same batch that Bob Higgy's HRO was out of. Millen's serial number was L248, and that receiver is now, along with Millen's 1930 station, in the Antique Wireless Association Museum, which I will show you on the next slide. This is W1 HRX, as you'll see above Joe's baseball cap bill. W1 HRX was Millen's call after the HRO was developed. And in front of Joe, to the left of that D104 microphone, is Millen's HRO, which is also a rack mount black HRO that is a little bit cleaner than Bob's, but looks exactly like it. And the rest of the two racks here are Millen's 1 kilowatt CW and AM transmitter. W1HRX has an interesting little story behind it. When Millen developed the HRO, the FCC was going to reassign his call letters, and they were going to give him W1HRO as his call. Unfortunately, they goofed, and instead of HRO, they made it HRX. I guess Millen didn't complain because he kept that call for quite a while afterwards. Here's a picture of some HROs during World War II, during and after. The HRO, as Millen designed and built it, went through a few minuscule changes. It went from 2.5 volt to 6 volt tubes. It went from round shield cans to square shield cans on the IF transformers, but it remained largely the same well into World War II and was bought extensively by the United States Navy. It was used by the English. There were a batch of HROs at the British station where they were intercepting coded messages from the Germans and from the German submarines. This is a picture over here on the left of a wartime HRO, an American HRO, and over on the right with the gray panel is a German copy of the HRO. You can see it looks almost exactly like the American HRO with a few differences, the gray panel being one. And if you look at where the S meter is on the American HRO, you can just about see it. There is a patch over the S meter hole on the German HRO. They copied the hole on the American HRO, but they didn't have enough meters to spare during the war to put a signal strength meter on a receiver, so they just put a patch over the hole. After the war, the plant that was making HROs in Germany wound up in Russian hands in East Germany, and the Russians continued to build HROs for themselves for several years. Over on the right-hand side, you'll see an Australian copy, pretty close, of the American HRO. They built that during the war. And even down on the bottom, there is a Japanese receiver that has the HRO plug-in coil set and the tuning knob right where the American HRO has it. The Japanese didn't copy the National PW and micrometer dial drive. They had a vernier drive themselves, but they did a lot to copy the HRO as well as did the Australians and the Germans. These are some other national receivers that came along in the 30s. In 1936, National developed the NC100 family, which was a 1RF, 2IF crystal filter receiver, much like the RME69. This one was more for a shortwave listener. It had 8 watts of push-pull audio. However, they also had a version of it. They initially made a special for Jim Millen, which covered only the 160 through 10 meter ham bands. But it became well known and so popular that they built it for amateurs as well. And it cost a good bit less than the HRO. In 1940, after Millen had left National updated the NC100. You can see that the NC200 here, which has the same basic layout, had both band spread, the ham bands, and the general coverage range from the bottom of the broadcast band to 30 megahertz. And it was built in 1940 and 41, and after the war it became the NC240D, which was built through 1949. Hammarlund also updated their receiver line. The first thing they came up with to replace the Comet Pro was the Super Pro, and this was indeed a super top-of-the-line receiver. The SP10 in 1935 had 15 tubes, 2 RF stages, 3 IF stages, and a crystal filter, and it covered from the bottom of the broadcast band to 20 megahertz. The SP110, which came out in 1937, added the tube, had variable IF bandwidth as well as the crystal filter, so that you could tune from 3 to 16 kilohertz for either good selectivity on AM signals in the ham bands or broad selectivity for broadcast selectivity on the broadcast band or the shortwave bands. And you could get a Super Pro that covered either to 20 megahertz from the bottom of the broadcast band or from 1.25 megahertz up to 40 megahertz in the SP110 series. Hammarlund also brought out a medium-priced receiver in 1938, the HQ120X. It has 1 RF and 3 IFs and a crystal filter. It has a noise limiter, diode clipper type, and it has calibrated ham band Bandspread, which you can see over there in the right-hand window. This was a very popular receiver in its day, and it was the father of other HQ receivers like the 129, the 140, the 150, through the 180 that Hammarlund brought out in the post-World War II era. So, in the latter 30s through 1941, most hams were using commercial receivers, 80% by 1938 and over 90% by 1941. The major manufacturers were, as we've mentioned, National, Hammarlund, RME, and Hallicrafters. National made mostly mid and higher price line receivers, including the HRO, and the family of the HRO was built until 1964 with the HRO 60. National made a lot of their key components, and their receivers were superior in electrical and mechanical quality. And even today, if you get a hold of a National receiver from the 30s or the 40s or the 50s, you'll get something that is still able to work quite well. Hammarlund made only mid and higher price level receivers, and they also used special custom-built components, and Hammarlund receivers survive well from that era. RME made only one midline receiver, the RME 9D, the RME 69, and RME 70 and RME 45, all 1RF, 2IF Crystal Filter designs. They stuck with that design ever since the RME 9D. They did make heavy die-cast aluminum chassis, but they used commercial components for their tuning capacitors and other things. So RME receivers tend to be a little more loosey-goosey these days. And then there was Hallicrafters. Hallicrafters was like nobody else. They were a terrifically prolific manufacturer of both receivers and transmitters. Not counting the crystal and non-crystal models of their receivers, they brought out 40 different receiver models from 1934 to 1942. And they brought out 6 different amateur transmitters. They covered the price spectrum. Their cheapest receiver was their Skybuddy line, which was $29.50. And a lot of people used the 5T and the S19 and the S19R Skybuddies to start their way into ham radio. They went all the way from the Skybuddy to the top of the line Super Skyriders, and the last of the Super Skyriders was $160, the SX28. And they even brought out a DD1 Skyrider Diversity, which was 2 receivers in one cabinet, for $550 in the late 30s. Moore, in his book about communications receivers, depicted Hallicrafters as specializing in giving the most possible features for the dollar and in bringing new developments to market in the fastest possible time. They used almost all purchased components, low-priced, high-volume parts developed for broadcast receivers. So a lot of the Hallicrafters receivers from the 30s that you get a hold of these days can be a bit loosey-goosey, especially in the tuning line. But there's certainly a lot of them, and a lot of people started with Hallicrafters receivers. They gave you a lot of bang for the buck. This shows you the 1939 line for the Hallicrafters receivers. The S19R Skybuddy had 6 tubes, no RF stage, 1 IF, a BFO. It covered the broadcast band through 46 megahertz. And it was the predecessor for the S38 Hallicrafters after the war. For an extra $20, you could buy the S20R Sky Champion, which had 9 tubes instead of 6. It had an RF stage, it had 2 IFs, and it had a noise limiter. And also covered 0.54 to 44 megahertz. For an extra $20 above the S20R, you could buy the Skyrider Defiant, the SX24. It also had 9 tubes, but it added a crystal filter, calibrated bandspread for the ham brands in the middle dial up there, and an S meter. And if you wanted to go another $30 or $28, you could buy the Super Defiant SX25, which had 12 tubes, and built out the SX24 by adding a second RF stage and about 10 watts of push-pull audio output. Compare that, for example, to the HRO, which was $170 or so for 2 RF stages, and didn't have the push-pull audio out, didn't have the noise limiter. You got an awful lot of receiver for your money with the Hallicrafters. In 1940, Hallicrafters came out with the last of their Super Skyrider receivers, the SX28. And this guy is a real monster. It has 15 tubes, 2 RFs, 2 IFs, one of James Lamb's noise blankers, 10 watts of push-pull audio output, and covers from the broadcast band through 43 megahertz. A good many SX-28s, I understand, were sent to Russia during the war on Lend-Lease. And the SX-28 came out in an A model around 1944 or 45 and was produced for a short period of time after the war as well. Hallicrafters also introduced their Sky Traveler, which is a portable receiver. It was popular, I understand, during the war with quite a few of the troops. Has 1 RF stage, 2 IFs, a BFO, so you could use it for ham radio or code reception, and it would run on AC or DC power or batteries internally. It also has a built-in antenna that you'll see sticking up there on the right-hand side of the top. In this was the first of a number of portable receivers like this that Hallicrafters came out with, sort of super zenith transoceanics, if you will. Hallicrafters also built transmitters, starting with the HT1. These show 2 of the more popular ones. The HT4 came out in 1938 at only $695. Rather than being a relay rack kind of guy, it was built in a squatter version. 16 tubes in there, crystal controlled, ran 450 watts on CW, 325 watts on AM, had plug-in coils and plug-in tuning units, covered 160 through 10 meters. The HT4 was drafted and became the BC-610 in World War II and ran around in an awful lot of trucks along with a receiver and became a liaison transmitter for the Army during World War II. The guy down here on the bottom is the HT6. It was a bit smaller, more like a receiver-sized box. Has 8 tubes, including an 807 in the output. Gives you 25 watts out on CW and AM, and with plug-in coils, can cover 160 through 5 meters. This was sold as the companion transmitter for the SX24 and SX25 receivers. By 1940, directional antennas were very popular. A lot of people were using fixed wire beams like rhombics and V's. The 8JK was a 2-element close-spaced phased array antenna, which gave you 4 dBd, dBs above a dipole gain, and was bidirectional. And the 8JK is an interesting antenna because it can be loaded up not only on its fundamental, but on all frequencies between its fundamental and the second harmonic. So even today, an 8JK, for example, for 20 meters, can be good for all the bands between 20 and 10 meters, and gives you good bidirectional capability. Also, the Yagi was becoming popular. And we, of course, know that Yagis come in 2 or more elements and are unidirectional. 3 elements giving you typically 8 dB gain over a dipole. World War II was a big game changer for amateur radio, and of course for everybody else as well. In 1939, the belligerent countries in Europe, their hams disappeared from the air. By the middle of 1940, United States hams were prohibited from communicating with any foreign country stations. And in the latter part of 1941, 160 and 80 meters in particular were being taken over, or were scheduled to be taken over partially by the United States Army for military exercises. Of course, things really changed for us here in the United States on December the 7th, 1941, when all hams went off the air for the duration. A lot of the equipment that served in World War II was drafted amateur radio or otherwise shortwave equipment by National, Hallicrafters, and Hammarlund in particular. There was very little new development of HF communications equipment done during the war. We just made an awful lot of the designs that we already had on hand. The new development work went into radar, VHF and microwaves, and radio location. The radio location system, known as LORAN, was plopped down in 160 meters because that frequency was available, and it occupied 160 meters for years after the war. VHF gear was particularly used for airplane-to-airplane communications, first in Britain and then with American sets as well, and it produced a lot of 2-meter gear directly useful to hams after the war. Radar and microwave gear weren't directly useful to hams, of course, but they were certainly great for parts. I had a radar power supply sitting in my ham shack in the 50s that was heavy and took up a lot of room, but it certainly provided power for almost anything my brother and I wanted to do. Well, that's the end of the 1930 to 1945 section, and thank you for sticking with me for this period of time. And look for part 3 of this talk, which will pick up at the end of World War II and take us up to the present.